My name Muhammad Yusri bin Wahab.
Hi, I'm Fakrun.
I'm Wafi.
And me, Afi.
And we are from Geng Ilmu Hisab. In physics, there are two types of motion. First dimension and second dimension. In first dimension, we will study about speed, acceleration and free fall. In second dimension, the object will move both in x and y direction. If any object thrown in the air, the object will move in projectile motion. If air resistance and rotation of Earth are neglected, the shape of projectile is curved in the shape of parabola. X direction is a horizontal and Y direction is a vertical.
Now I'm gonna explain about the theoretical part of the projectile motion. I'm gonna brief shortly about the formula.
As we have seen from the graph, we can obtain the equation for the initial speed of the projectile. By Newton's second law of motion, we know that F is equal to mass times acceleration. So in this graph, we can conclude that the acceleration is equal to the gravitational force. By applying simple integration, we can obtain the formula for R. Substituting the values of V naught and R naught, we can get the equation for the R. By rearrange the term, we have the ideal projectile motion equation. From the projectile motion equation, we can obtain two different equations, where x is equal to V naught cos alpha t and y equal to V naught sin alpha t minus half gt square. By doing some simple calculation, we can obtain the graph of the projectile motion, which is a parabola.
After we have plotted the projectile motion graph, we can obtain the three data. First, peak of the projectile. Second, time of flight. And lastly, range from origin.
In order to get the highest point of the projectile, the vertical component of the velocity is 0. So, by rearranging the equation, we can get the time when the projectile reaches its speed. Substitute the time into the equation y, then we can obtain the peak of the projectile. Next, to calculate the time of flight, so we must set the vertical component equal to 0, where y is equal to 0. Then by rearranging back the equation, we can get the total time of flight. Lastly, range from origin. The total time that we have obtained can be substituted into x to obtain the range. Last but not least, from the graph of the projectile motion, we can obtain four important information. First, vector equation. Second, highest point of the projectile. Third, time of flight. And lastly, range from origin.
For the part of recommendation, we can improve the accuracy for this experiment by considering three factors, which is air resistance, angle of inclination, and the third one is the force applied to the ball. If movement or wind can affect the result, and it will make the result we get will be inaccurate. So in order to get better result, we should conduct the experiment in closed room where there is no wind or air resistance involved in this experiment. The second one is the angle of inclination. For example, when the angle of inclination is big, the position of the ball will be high in the air, whereas if the angle of inclination is small, the ball will be low in the air. So it is depend whether we want to get high position or low position. So we must set it as a fixed constant. Lastly, we can improve the accuracy of this experiment by setting the force applied to the ball as a constant. In order to reduce the error, we should use machine instead of human, because machine makes less mistake than human. So by using machine, you can set the force applied to the ball as a constant, so it's same every test, so we can get better result from this way.